Hello everyone, and thank you Peter for the introduction. Yes, today I'm going to show you a little bit of our research regarding the possibility of enriching beam representation semantics to web semantic ontologies. So during the presentation we will pass through some motivation, so why semantic enrichment is important, in particular from a architectural design perspective. Then we will compare it with beam ontologies presentation schema. We will then present the beam semantic reach platform, that is this small application that this small platform that we created, and then the prototype of this platform. And then at the end we will have some discussion. So which are the objectives of our research? We have a general objective, that is the idea of representing or enriching semantic representation in information models, especially through semantic web technologies, in order to improve compression and collaboration among the different actors involved in the design process. This research is actually part of a large research project that is carried out at Firenze University of Rome, that was defined several years ago as building knowledge modeling, that focuses on knowledge-based support systems for collaborative design. Within this large framework, what I'm going to show you today is just the answer of a very specific objective. It is the development of a small platform and prototype that connects a beam environment and the knowledge-based development ontologies in order to enhance the level of semantics embedded in the beam models. So, when enriching beam semantics, there are several motivations regarding that. We focus in particular on two aspects. The first one is the representation spectrum. What does it mean? It means that usually beam information models are mainly focused on the representation of the product of the process, that is the building, especially in terms of its technological components and its constructional aspects. But when we carry out an architectural design process, we actually have a lot of knowledge provided from different domains that contribute to the definition of this product. At the end of the process, we have the product, but we lose all this other knowledge that was shared, exchanged during the design process by the different actors. And this is actually part of the knowledge that it's going still to be necessary to fully understand the design. The other limits that we talked a little bit about is the weakness of semantics. At the end, we have these beam models that are very rich databases, completely extendable. I mean, they can infinitely store data in there. But in the end, if we don't provide a sufficient interpretative context on any single information, we are losing the possibility to let other actors from different disciplines to understand the real meaning of this information. So, the use of information ontologies is quite well known in the AC field from the 90s, and there are several advantages on the use of semantic web technologies and the techniques as the information ontologies. We just figured out some of them. The first one is the homogeneity of information. We are dealing with the different domains that contribute to the definition of the building, and we need a representation schema that is homogeneous, that allows us to formalize in the same way knowledge related to the building, to the context, to the users, operations, norms, regulations. And this kind of homogeneity allows us to arrive to the second point, is the computability of knowledge. We can, if we use this kind of, if we use information ontologies, we can allow computers to pass through this knowledge, formalized knowledge, and acts with queries, with coherence checking rules, operational rules, and so on. And there is also another aspect that it's an advantage of the use of information ontologies. That is the flexibility and extendability of the knowledge base. This means that if we have, I mean, designing a building is a process that has an incremental amount of knowledge, and especially if you compare actually to more different design projects. And if we, flexibility and extendibility allows us to adapt an original knowledge base to different aspects that are related to the building design. So, very briefly, we just now going to compare some BIM representation schema that is quite well known in the softwares and in the ontology representation schema. So in the BIM representation schema, we actually have families that are general classes that represent specific, an abstraction of some technological components. Then we have types, family types. There are also different names depending on the software that are actually specifications in terms of some values of the abstract families. Then we have instances that they are actually what we use to populate the model. So it's the actual representation of the single technological component of the building. Then we have properties that add features to represent features of those families and that they are inherited in the instances. Then we have relationships and the rules and constraints that if we just look at BIM softwares, usually we have those kind of relationships and the rules and constraints are very limited to the constructional coherence of the building. So we have the assembly relations, then we have some coherence checking regarding difference between floors and so on. On the other side, ontologies representation schema is quite more flexible. We have classes, actually concepts, they consider them as classes, and those are organized, can be organized in multiple levels. So we don't have the 3 layers structure as in the BIM environments, but we have more. We can have a lot more deepness of the taxonomies and of the semantic networks. Then we have instances that are derived from those classes. We have properties. We can have any kind of properties that we want, and then we have relationships and rules. And in this case, we are more flexible. We can add also relationships related to other knowledge domains that we can connect to our model and so on. This is actually reflected also in the database structures. This is just the structure of a BIM model from Revit, where actually classes are organized in terms of tables, and then we have properties in terms of columns of each table. We have instances that are the rows, the entries of those tables, and then we have a very rigid set of relationships. On the other side, we have ontologies and multi-networks, so where concepts that are connected to a lot of relationships, many relationships, and that we can actually customize in order to reach the full representation of the building and of the knowledge related. And if we look at the transposition of the semantic network to a database, you can see that it's actually a single table where everything is where the distinction between classes, instances, and so on is mainly related to the syntax of the formalization. So, starting from this comparison, we developed a sort of conceptualization of this structure of this platform, where we have the BIM environment on the one side, we have the knowledge-based developed ontologies on the other, and then we have in the case of the BIM environment, it's quite obvious. We have the BIM environment and then we have the database related to it. On the other side, on the ontology database, we have, on the ontology side, we have the semantic networks that we translated to the ontology database. And what we actually worked on is this BIM semantic bridge that works on these 2 databases, and it actually allows 3 kinds of operations. The first one is the mapping. So we can create correspondences upon entities represented in the knowledge base and in the BIM environment. Then we have the comparison, so we can check if there are coherences, incoherences, and different values among the same property stored in the bottom in the two environments. Then we have data transfer, so we can actually translate data from one side to the other in order to have the general coherence of the entire system. From the designer perspective, we actually have what is the general idea is to have a designer that is working not anymore just in a BIM environment, but is working on a connected knowledge-based environment developed through ontologies with a good interface, and behind them there are these two knowledge bases, and the application, the BIM semantic reach, allows to generate to provide coherence among these two databases. So I will now show you just a little bit about the application that we developed. It's quite easy because it was a very cheap experiment, actually. The platform is organized, this prototype of the platform is organized into 3 areas. As you can see here, on the left side, there is the ontology schema. This just is connected in real time with the ontology database. On the other side, we have the BIM schema, so we have the taxonomies derived from the BIM database. And on the bottom part, we have the mapping area. It's where all the classes, properties, instances are connected each other from the two sides. Then we have some operation that we can perform. The first one is the data source. So if you just click on the data source, you can select the BIM database that you want to connect, the ontology database, and the mapping schema. Then you have the mapping button that is useful to create correspondences about classes, properties, and instances in the two environments. Then you have the comparison about all of the two taxonomies, and then we have this data transfer that can be on a single value or to the entire system from one side to the other. So talking about the family mapping, that is the first step. When you open this when you have these two taxonomies, you can actually click on the two. I mean, you can create the correspondence between a class formalized in the BIM environment and a class formalized in the ontology environment. And the mapping is stored in a TXT file that is represented in the bottom part, that actually allows you to, that actually controls also the kind of mapping that is performed. For instance, if the mapping is related to classes, you have the 0 index. If you are mapping instances, you have the 2 index. If you are mapping properties, the 1, and so on. And this is a TXT file that is saved, that can be reused in different, also in different projects. So you don't have any time to recreate all this mapping system. This is the properties mapping. As you can see here, is in this case we are mapping two object properties that are actually very similar to relationships among entities. And then we are mapping instances. The mapping of instances is actually a little bit more tricky because each project, different projects can have the same classes mapping, but the instances are always different because each project is different and then it has different instances. Similarly, we can have this ontology comparison, BIM ontology comparison. So the system just look at the two databases and see if the data is coherent, if there are some families or instances or properties that are not mapped. And it also provides us a sort of indication of each of the different possibilities. So if there are missing, it's red. It's if the value is not coherent, you can have the red names. If you have in orange the missing data, and you have also blue data that represents all the entities that cannot be mapped. And then we have the ontology data transfer. So BIM ontology data transfer. So you can actually transfer the values stored in the two databases from one side to the other. We can do that by single updating the values. That is quite, it's working quite well. You can also do a sort of bulk update. It means that you update all the values from one side to the other. This is a little bit more dangerous because you don't actually have a control of what is updated. So after that, you should redo a sort of comparison and see if everything is working. Okay, this is just the transfer of data. So skipping to the conclusion, talking about more generally about BIM ontologies, we believe that BIM ontologies represent, and their integration represents a possible way to reach building representation from the architectural building design perspective. As I showed you before, this BIM semantic enrichment is especially oriented to overcome two limitations. One is the limitation of the representation spectrum, and the other one is the poorness of the semantic level that actually hinders the collaboration among different architects. What we presented is a robust platform that supports this kind of BIM ontologies integration that allows to include in the representation of the general model of all the knowledge that is shared, exchanged, and managed during the design process. And just talking about the prototype, this prototype was developed by using almost all the software and application that is already on in the market. So that does not mean that we are looking for completely different tools, but we can just work in harmony with what is already existing. Future developments, as I told you before, this is the first step of our ongoing project. There are several things that we have to work on in order to improve this application and this prototype. The first one is related to automation and coordination of the two environments, especially from the BIM side. On the ontology side is quite more dynamic and flexible, but on the BIM side we have several limitations in terms of exporting databases, coherence checking, and so on. Then we have the idea generate instances from both sides. From now we have to, create the instance on the BIM environment, create the instance in the ontology environment, and we have difficulties. It's an operation that you are going to do 2 times for each instance. We have to solve that. Then we have to use more powerful ontology editors. We use Protege in the first step. It's an open source ontology editor, but it's still it has some limitations. And we have to also assure coherence checking between the two environments, because sometimes you go the operation and then one of the two environments say that there's something that's not coherent with the approach. And at the end, we would like to design an interface that doesn't look like Windows 95. So thank you for your attention. If there are questions.